MCA Prep Day 3 in our MCA review packet. We're going to work on reviewing Chapter 10 today. First, we have our benchmark 8.1.1.1. Classify real numbers as rational or irrational. Know that when a square root of a positive integer is not an integer, then it's irrational. Know that the sum of a rational number and an irrational number is irrational, and the product of a non-zero rational number and irrational number is irrational. Number 1, the number 0.4 repeating is a repeating decimal. Is it a rational or an irrational number? We learned that terminating decimals and repeating decimals are always rational. So 0.4 repeating is rational. The reason that it is rational is because it can be written as a fraction. 0.4 repeating is equal to not 4/10, but 4/9. And I will show you that right over here. 4/9 means 4 divided by 9. 9 goes into 4 0 times. 9 goes into 40 4 times. 4 times 9 is 36. 40 minus 36 is 4. If I bring down a 0, you see that this pattern is going to repeat over and over. 9 times 4 is 36 again, and so on. So repeating decimals, instead of being tenths, hundredths, thousandths, and so on, the denominators are just one less. So they are ninths, or 99ths, or 999ths. Any repeating decimal can be written as a fraction. So a repeating decimal is a rational number. Our next benchmark, 8.1.1.2. Compare real numbers. Locate real numbers on a number line. Identify the square root of a positive integer as an integer. Or if it is not an integer, locate it as a real number between two consecutive positive integers. Draw a number line that correctly shows the location of the following two numbers. So here's my number line. Okay. I am going to go with numbers starting with 1 to 7. And what I want you to remember is that the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, the square root of 36 is 6, and the square root of 49 is 7. So the square root of 28, square root of 28 will be located in between 5 and 6 because it's in between these numbers, and it's only 3 away from 25 while it's 8 away from 36, so it's going to be closer. So I'm going to put my square root of 28 right here, closer to the 5. The next one is the square root of 45. That would be between 6 and 7 because the square root of 36 is 6 and the square root of 49 is 7. This one is going to be closer to the 7, so I'm going to put my square root of 45 right here. Our next standard, 8.1.1.3, determine rational approximations for solutions to problems involving real numbers. Number 1, a rectangle measures 7 centimeters by 11 centimeters. Part A, what is the length of each diagonal expressed as a radical? Okay, so it's a rectangle, and it's 7 centimeters by 11 centimeters. So 7 centimeters by 11 centimeters. And the diagonal means this. So what happened is I've just created a right triangle here. So what is the length of the diagonal? Well, that diagonal happens to represent the hypotenuse in my right triangle. So a squared plus b squared equals c squared. The Pythagorean theorem is what I need to use. So I know that the legs are 11 and 7. I don't know my hypotenuse. So if I square those, 11 squared is 121, plus 7 squared is 49. So I can add those together, and I get 170 equals c squared. So then I would need to take the square root on both sides. So the diagonal is the square root of 170 centimeters. Because it said to express it as a radical, I'm not going to do anything else with that square root. I'm going to just leave it alone. So the square root of 170. Then on part B, it says to the nearest tenth. This is where you want to use a calculator. Or if this was a question where you could not use a calculator, you would want to approximate that square root. So you would want to think about what perfect squares it's in between. And we know that the square root of 100 is 10, 121 is 11, 144 is 12. What you may not remember is that 169 is 13, so it's just a tiny bit higher than that. So my approximation is that it's probably about 13.1 centimeters. Now, if you were allowed to use a calculator on this question, you could certainly put it in your calculator, and it actually is 13.0. So without a calculator, I thought it would be about 13.1, but checking on my calculator, it's actually about 13.0 because it's 13.03, so it would round down. So to the nearest tenth, with the calculator, 13.0 centimeters. Without, 13.1 would have been okay. Our next benchmark, this is actually a little bit better of a fit with chapter 1. So part A, so we 8.2.3.1, evaluate algebraic expressions, including expressions containing radicals and absolute values at specified values of their variables. So number 1, evaluate each expression for x equals -3 and y equals 7. So the absolute value of x, I put the -3 in for x, minus the absolute value of y would look like this. Then individually, those absolute values, remember absolute value is the distance from 0 on a number line. So -3 is 3 units away from 0, 7 is 7 units away from 0, then you would subtract them. So inside the absolute value bars, when it's down to one number, then you take the distance from 0. And distance is always positive. Now on part B, I've only got one set of absolute value bars, so it's x minus y. This is a different problem than the first one to simplify, because within those bars, -3 minus 7 is -10, then the distance from 0, -10 is 10 units away from 0. So it makes a difference that we had separate absolute value bars around each number versus the difference x minus y in one set of absolute value bars. So we have two different answers here. Okay, 8.2.4.9. Use the relationship between square roots and squares of a number to solve problems. What are the solutions to the equation n squared equals 100? Well, n squared equals 100 is an equation, so we can solve it with our train track. The inverse of squaring a number is taking the square root. So I am going to take the square root on both sides. The square root of 100 we typically think of as just 10 because that is the principal square root. So that's one of the square roots. The other one is actually negative 10. Because if you think about it, we're looking at n squared equals 100. 10 squared is 100. But negative 10 squared is also 100. So that's why technically there are two solutions to this equation. It's just that the most common one to use is the positive root. So your calculator gives you only that positive or principal square root when there are really two of them. Now, this next one, part B, says an equation has negative 4 and 4 as its two solutions. So what could the equation be? Well, if 10 and negative 10, if we square both of those, we get 100. What happens if we square negative 4 and 4? Negative 4 times negative 4 is 16. 4 times 4 is also 16. So my equation is going to be x squared equals 16. If you solve that equation, you would get the solutions negative 4 and positive 4. 8.3.1.1. Use the Pythagorean theorem to solve problems involving right triangles. The two shorter sides of a right triangle are 8 centimeters and 10 centimeters. What is the length of the longest side? Well, the longest side is the hypotenuse, c. So, a squared plus b squared equals c squared. And we know the two shorter sides. They're 8 and 10. We don't know the longest side. So 64 plus 100 equals c squared. So 164 equals c squared. And then we take the square root. And c is approximately 12.8 centimeters. Now, part B, the two longer sides are 8 and 10. What is the length of the shortest side? Well, the shortest side has to be A or B. It can't be C. So I am going to say the shortest side is going to be A. So A squared plus B squared equals C squared. So this problem is a little bit different than the last one because we are given the longest side. So if I subtract 64, A squared equals 36. So then the square root of 36 is 6. So what they did was they gave you the two side lengths were 8 and 10, and they asked you to find the missing side. The first time we were missing the longest side, second time we were missing the shortest side. So it completely changed the problem. Okay, 8.3.1.2. Determine the distance between 2 points on a horizontal or vertical line in a coordinate system. Use the Pythagorean theorem to find the distance between any 2 points in a coordinate system. So point M is located at 3, -1. The length of MN is 5 units. What are the coordinates of N if N lies in quadrant 1? Okay, this might be a little tricky for some of you. I am going to bring up a graph. And I am going to shrink it a little bit to get it to fit better. Okay, so here's what we're talking about. 3, -1 is right here. My quadrants are 1, 2, 3, and 4. Okay, so now it says the length of MN. So this is point M. The length of MN has to be 5 units. What are the coordinates if N lies in quadrant number 1? So 5 units. 1, I'm going to move my M over a little for you. Okay, so 5 units. 1, 2, 3, 4, 5. So N has to be right here so that this length is 5. So that ordered pair is 3, 4. So 3, 4. What are the coordinates of n if n lies in quadrant number 2? Now it's getting trickier because now they're talking about a diagonal distance of 5. So I still have to start here at my point M, but to get a diagonal distance of 5, you may not remember this. It might take you a while to figure it out. So if I put a point anywhere in quadrant 2, I could find the distance. So I'm just going to show you to get you thinking here. So if I put a point right here, and I wanted to find that distance, we learned how to do the distance formula or the Pythagorean theorem. If I'm doing the Pythagorean theorem, it looks like this. So I would count, this side is 3, and I would count the base on the bottom, 1, 2, 3, 4, 5, 6, 7. So if I solved that, 3 squared plus 7 squared equals c squared. 9 plus 49 is 58. 58 equals c squared. The square root of 58, is that going to give me 5? No, that's not going to give me 5. That's going to be a lot bigger than 5. So if I know that my distance diagonally has to be a 5, maybe you remember that we had some special right triangles, and we had one that was a 3, 4, 5 right triangle. So that's what I need to create here, is I need to create a 3, 4, 5 triangle so that my hypotenuse can be 5. So I am going to go over 4, 1, 2, 3, 4, and up 3, 1, 2, 3, and this is where I think my ordered pair needs to be. Okay, so I think, right now, take a look at that right triangle. 3 and 4, so is this side 5? 3 squared plus 4 squared equals 5 squared. 9 plus 16 is 25. Perfect. So that ordered pair is -1, 2. -1, 2. If you are not familiar with right triangles so that you remember seeing this 3, 4, 5 before, it's going to take you a while to figure out where that point could be. So you could always use the guess and check method to find it. Okay, we are done for the day. So you should complete all of those pages in your packet. Each one of these examples that I went over has that page and then the following page that goes with it of practice problems. Good luck.